Hello everyone, and welcome to another episode of Math with Dr. War. Today we're going to begin our series on functions. Functions represents 26% of the items on the TASC test. Now the first step is vocabulary. There's a couple of terms we need to know. The first one is relation. When we talk about a relation, is a set of ordered pairs. Now we've seen ordered pairs before. I don't think I call them ordered pairs, but we know them as a point. So if you put a couple of points together, you get a relation. And remember, a point has an x value and a y value. So just remember, a relation is a set of ordered pairs or a set of points. Now, when you have a relation, they can ask you for the domain. The domain of your relation is just the x values in the relations. And we call that our independent variable. Now, if I wanted the domain for my relation here, notice I have some curly brackets. And I'm just going to write all of my x values in numerical order. So -1 is the smallest, followed by 0, then 1, and then 2. So whenever they ask you for the domain, just find the set of input values, which is the x in the relation. So just look for the x values, and that's your domain. When they ask you for the range, that is the set of output values, which is your y in the relation. So again, I'm going to write my y values as I see them. So I have 2, then 4, then -3, and then +3. And then I'm going to write them in numerical order. I do this because when I taught this last week, the students were struggling to put them in numerical order by just looking. So I find just writing them out as they are, as you see them in the relation, and then writing them in numerical order makes it a little bit easier. So here the smallest number is -3, followed by 2, then 3, and then 4. So this is my range. And always remember, the range is the dependent variable. So if you have a relation, which is a set of ordered pairs, you can find the domain and the range. For example, let me create a relation right here. So suppose we have a relation which is, let's say, 1, 3, -2, 7, 8, 9, and then one more, let's say 0, 8. So suppose this is our relation right here. My domain is all my x values, which are here. So these are all my domains. So again, I'm going to write them how I see them: 1, -2, 8, and 0. And then I'm going to put them in numerical order. So -2 is the smallest, then 0, 1, and then 8. So now they're in numerical order. And then if I have to find a range, that is all my y values, which is the 3, the 7, the 9, and the 8. And again, I'm going to write them as I see them in the relation because that's easier. And then I'm going to write them in numerical order. So the smallest is 3. Okay, then the next would be 7, then 8, and then 9. And that's my range. So if you're given a relation, you should be able to identify the domain and the range. Now, when we talk about a function is a special type of relation. And by a special type, it means that each input value, which is the domain, has exactly one output, which is your range. Now, the way to think of a function, and I thought hard about what real life situation represents a function, I could only come up with one, and it was airline seats. So you know when you buy a plane ticket, you get a seat. So that's why when I'm traveling and I see people at the airport and they call your flight, you notice everyone gets up and they're rushing to get to the counter to get on the plane. And I'm like, where are they going? They've been assigned a seat. So why rush? your seat will be there. So I don't rush. I sit, I wait, I let everyone get on, and I know when I get there, my seat will be there. So airline seats are functions because one person is only assigned one seat. Here I have some functions. Notice this is my domain, which is my X value. This is my range, which is my Y value. And notice that each domain has exactly one output. Look at the arrows. -2 is going to -4, -1 is going to -2, 0 is going to 0, 1 is going to 2, and 2 is going to 4. This is a function. Again, think of it as airline seats. So think of the domain as the person and think of the range as your seat. Okay, so this person has their assigned seat. Every person has an assigned seat. Let's look at number 2. Again, this is my domain and this is my range. Notice my domain, I have -4, -3, -2, -1, 0, and 1. And notice -4 is going to 16, -3 is going to 9, -2 is going to 4, -1 is going to 1, 0 is going to 0, and 1 is going to 1. Now, you're probably wondering, how is -1 and 1 going to 1? So it kind of looks like these two people have been assigned the same seat. But remember, on planes, you got a left-hand side and a right-hand side. So there are actually two number 2s on the plane. One is A, B, C, and the other one is D, E, F. So maybe this one right here is one person is sitting on the left-hand side of the plane and one person is sitting on the right-hand side. Always remember that with the domain, you should have exactly one arrow leaving your domain, okay? Your domain cannot be used twice. And another way I think about it, all of the numbers should be unique. So this is a function. Let's look at the third mapping. Now here's my domain, here's my range. Now I have -2 going to 2, but -2 is also going to 4. So this -2 here is being used twice. Now think about it. If you're on a plane, how is this person having 2 seats? So this makes this not a function. -2 was, there was 2 arrows leaving the -2. Always remember, in your domain, you should have one arrow leaving your domain. Your domain, the value should only be used once. When I got here, I noticed -2 was being used twice. It was going to 2 and it was also going to 4. It's not a function. So let's look at some problems. So on the TASC test, your problems will look like these. Now the first one, it says here, which relation represents a function? And remember, for your function, we're only looking at the x values, and your x values should not repeat. Notice the zeros here are repeating, not a function. Okay, let's look at number 2. -7, -7, not a function. I'm going to write NF for not a function. Okay, let's look at our x values. 2, then I have 6, but then 6 repeats itself, not a function. Okay, let's look at the fourth one. We have -6, -3, 1, and 6. All of your values are different. -6 and +6 are not the same number. Every x value is different, so this is your function. When you have to determine if something is a function, look at the x values. If all of the x values are different, it is a function. If any of your x values repeat, not a function. Let's look at number 2. It says, which set is a function? 3, okay, 3, all of the x values repeating, not a function. Okay, 1, 3, 4, 2. All of my x values are different, So this is a function. So my answer is 2. I don't need to go any further. I didn't circle number 4 up here. Now if you want to go, let's see. Here I have 6, 7, 8, 6. The 6 repeat themselves, not a function. Okay, let's look here. 0, 3, 0. Okay, the zeros repeat themselves, not a function. Let's look at the third example. Which set of ordered pairs does not represent a function? So they want that does not represent a function. Please be careful with the word not. I find that when students are in a test, they know when something is a function. So when they get the question, they're always looking for when it is a function. This question wants to know when it is not a function. So let's look. 3, -2, 4, -1. This is a function. Let's look at number 2, 3, and then the 3 repeats. So the 3 here is being used twice, not a function. So my answer is 2. If I go on again, 3, 4, 5, 6. These are all different. That is a function. Last one, 3, 5, 4, -1, function. Okay, you don't have to go all the way here. I'm just trying to explain when something is a function to when it is not a function. Now sometimes they give you a table. Again, remember this is our x value. Remember f of x really is our y. We're not concerned with the f of x. We're more concentrating with the x value. So they want to know which table represents a function. I noticed that the 2's appears twice. They repeat. So this is not a function. Okay, number 2, I see 0 repeating itself. Not a function. Okay, number 3, I see 3, 5, 7, 9. Every number is different. This is a function. So your answer is number 3. Okay, sometimes you may give a mapping. This is called a mapping. Which relation does not represent a function? And the key word here is not. So notice when it is a mapping, one arrow should be leaving each value in the domain. So notice here 3 is going to 4, one arrow is leaving 5, so this is a function. So each domain value should have exactly one arrow leaving. Okay, let's look at number 2. The 3 is going to 8, the 5 is going to 4, and the 7 is going to 6. This is a function. Okay, here there's no arrow leaving the 3. However, notice there are 2 arrows leaving the number 5. Because of that, this is not a function. Remember, your x value can only be used once. If we think of the airplane situation, this is telling me that 5 have 2 airline seats. And that is not possible. You can't have 2 airline seats for one person in our perfect mathematical world. Not a function. Notice with number 4, each domain value has one arrow leaving. So this is a function. Remember, we do not care about the y value. We only care about x. X should only be used once. All of the x values should be unique. When it's a mapping, there should be just one arrow leaving every domain. If you have 2 arrows leaving a domain value, not a function, such as this one here. Notice it's making like a less than sign. Now, they usually give you some problems where you have to use some critical thinking. So the first one says a function is defined as, we have 0, 1, 2, 3, 5, 8, and 7, 2. Clearly, if I look at my x values, they are all different, which means that this is a function. Isaac is asked to create one more ordered pair for the function. Which ordered pair can be added to the set to keep it a function? Now we need to keep this a function, which means we cannot use a 0, a 2, a 5, or a 7 in the x values. So let's look at our x values. The first one has a 0. We can't use that. If we use this, this would make our relation not a function. We need to keep it a function. Okay, here's my x value 5. Do we have a 5 in our original relation? Yes, can't use that. Okay, here, this has a 7. Do we already have a 7? Yes, we can't use that. So our only alternative is 4, 1, 3. We can use this ordered pair and this would keep it a function. Remember, to keep it a function, all of the x values must be unique. The x values cannot repeat themselves. So we couldn't use a 0, a 2, a 5, or a 7. So we were looking for a number that was not either of these x values. And the only one that met the criteria was 1, 3. Number 2, given the relation R, -2, 3, A, 4, 1, 9, and 0, 7, which replacement for A? So we need to replace A and make this relation a function. So we need to make this a function, which means A cannot be a -2, it cannot be a 1, and it cannot be a 0. Okay, which means this one is out of the answer. We can't use -2, so that's out. We can't use 0, that is out. The only number here that is different from -2, 1, and 0 is 4. So that's our answer. Last question. The relation defined by the set of ordered pairs 0, 2, -2, 2, 1, 4, 4, 1, and 0, -1 is not a function. So again, this is not a function because the zeros appears twice. Which of the ordered pairs listed below, if omitted, so omitted means to take out. So we need to take out something from this relation, will make this resultant set a function. Now, to make this a function, so we got to remove a 0. So let's go and see. So we need the 0. Here it is. So we can remove 0, 1 and make this a function. I hope this has been helpful. Good luck in your TASC examination.